Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be learning the introduction part of mechanics of solids as well as the overview of the syllabus. So let us understand the introduction of mechanics of solids, and this particular subject, mechanics of solids, is familiarly known as strength of materials, as well as it is also known as mechanics of materials. These are the other names of mechanics of solids. And as far as the introduction part is concerned, let us look at this. Let us define what is meant by mechanics. Mechanics is the branch of physical science which deals with the analysis of forces, the rigorous analysis of forces, and which affects in either the body is at rest position or it may be in motion. If it is in rest position, we call it as a statics part of it, and if it is in motion, that part we call it as dynamics of engineering mechanics. So this is what exactly the definition of mechanics. Let us look at this overview of mechanics. Overview of mechanics. Mechanics is broadly divided into two important subjects. One is it is the rigid body mechanics. We call it as rigid body mechanics, or you can call it as initially mechanics of solids, depending upon the working fluid, mechanics of solids, and mechanics of fluids. Here, mechanics of solids are further classified into two important areas. That is, one is rigid body mechanics, and other side it is deformable body mechanics. It's mechanics of deformable bodies, deformable bodies. This is what exactly the broader classification. Rigid body mechanics, that means you are assuming that the body is assumed to be rigid. There is no change in dimensions of the body after the application of the system of forces. So that body is called rigid body, and the engineering mechanics is the subject which is known globally, the rigid body mechanics. And here the mechanics of deformable bodies. So as usually, if you look at that, if a body is subjected to forces, the body is going to deform. Here also the body is going to deform, but we are not considering the deformations. So we are neglecting the deformations in engineering mechanics, and whatever the small deformations are going to exist, we are going to consider in mechanics of deformable bodies. That is nothing but mechanics of solids. So let us look at a simple example. I am considering a simply supported beam. A simply supported beam subjected to a midpoint load P, and left side end A, and support reaction is RA, and the right side support is RB. The reaction is RB. RA and RB are the reactive forces due to the external force acting exactly in the midpoint. So these magnitudes are P by 2 and P by 2 from symmetry. Both are equal. Both are equal, and you know this forces, how we are going to calculate using the principles of mechanics as well as the Varignon theorem. So this value Ra, this is nothing but support reaction. The support reactions we are able to calculate using the principles of mechanics as well as the Varignon theorem. And here the moment you talk about deformable bodies, because under the action of the forces, here you can observe that the actual phenomena is going to have like this. That means under this external force P, the body is the beam is going to deflect like a bow. That means here the moment you apply the external force at a point, how the force is transmitted from the point to the support by means of what happens when the load is acting at a point, the resistive forces are developed in the material. That means you are going to understand the internal behavior of the material in mechanics of solids. Here the resistive forces are developed and the forces are being transferred, and that means the moment once it is resistive forces developed because of the elasticity of the material, the beam is going to bend like a bow. So you are going to have the deflections and deformations in the material. So here in engineering mechanics, you are not going to consider, that means you are ignoring the deformations and deflections, and in mechanics of solids you are going to consider the deformations and deflections, however small it may be, and by means of that you will be evaluating the strength of the material. And that is the reason the subject is also known as strength of materials. This is a brief introduction or overview of you know mechanics. Let us look at the content of the syllabus, which we are going to discuss in detail in mechanics of solids. The unit 1 is, the title of the unit is simple stresses and strains. Unit 1 is simple stresses and strains. Unit 2 is more circle, and you have another topic and torsion, the second topic of this particular unit. Unit 3 is SFD and BMD, shear force diagrams and bending moment diagrams. The title of the unit is shear force diagrams and bending moment diagram. Unit 4 is flexural stresses, and unit 5 is deflections. Unit 5 is deflections, and unit 6, that is the last unit, you have thin and thick cylinders. Thin and thick cylinders. If you observe carefully in the total syllabus, we are going to discuss rigorously about a one-dimensional structural member, that is beam. Only in last unit we are going to discuss thin and thick cylinders, and from unit 1 to unit 5 we are going to do rigorous analysis of a one-dimensional structural member, that is beam. Now let us look at this, the contents of the important subtopics of each unit. So let me give the details of this. Unit 1. In unit 1 we are going to discuss the topics like the definition of stresses and strains, and you are going to understand the stress and strain curves for ductile material as well as brittle material, and then you will be able to understand the relation between Young's modulus of rigidity, and bulk modulus. The relation between EGK you are going to understand, and after this topic you are going to switch over to the analysis of varying cross sections. the stresses as well as strains in varying cross sections, and you are going to do even compound bars. Compound bars is again you have compound loading, the multiple loads, as well as compound materials. It is compound loading and compound materials also you are going to discuss. And you are going to discuss the thermal stresses, the stresses developed due to rise in temperature, thermal stresses, and lastly, the strain energy concept. Strain energy, and you will be analyzing the stresses developed due to strain energy developed in the material because of the various types of loads like gradually applied load, suddenly applied load, impact load, and shock energy. All this you are going to study you know in first unit, and this is more or less the all the fundamentals you are going to discuss in this particular unit. And let us look at in unit 2. Unit 2, we are going to discuss, here it is more circle. So in more circle, mainly you are first of all you are discussing the analysis of biaxial stresses, biaxial stresses with shear. That means you'll be able to find out the stresses on a given element, biaxial stresses, that is sigma x, sigma y, and tau xy, and you will be able to find out the normal stress as well as shear stress randomly at an angle phi with respect to the vertical axis, that is y axis. So that is the first step we are going to discuss, and after this you will be defining what is meant by principal plane, and again you will be understanding the principal stresses. By analytical method, you are going to write the expression for the Morse circle also, Morse stress circle. That is what is graphical method, Morse stress circle. And lastly, the second topic you are going to discuss, that is torsion of circular shafts. So these are the various topics in Unit 2. And Unit 3, you are going to discuss the topic shear force diagram and bending moment diagram. It is shear force and bending moment diagrams. So before understanding this, you will be understanding the different types of beams, especially in this types of beams, that is simply supported, cantilever, and overhanging beams, and you will be understanding the types of loads also. You have concentrated loads, distributed loads, and varying loads. Under these loads, for various types of beams, you will be drawing the shear force and bending moment diagram, and you will be understanding the relation between shear force, bending moment, and load intensity also. Load intensity. So these are the various topics of Unit 3. Flexural stresses. So here, the flexural stresses. In this, you will be deriving very firstly the bending equation. You are writing the bending equation. This is one very important equation with assumptions, and you will be calculating the bending stresses using this bending equation. It is called bending stresses. Bending stresses using your bending equation for various cross sections, maybe I section, T section, C section, or maybe a rectangular section. Will be calculating the strength of the material, that is what is section modulus also you are calculating, and you will be uh, writing the expression for shearing stresses also, shearing stresses. So here bending and shearing stresses together is called flexural stresses. That's what is your name of the unit. And fifth unit is reflections. First of all, you are writing the expression for the differential equation of elastic line, and you will be using a double integration method. It is called a double integration method to calculate this integration. That is one method of calculating. If you have multiple loads, you will be using other method. That method is called Macaulay's method. It is Macaulay's method is very important from examination point of view also. It is Macaulay's method. Macaulay's method, double integration method. This is also say double integration method and Macaulay's method. This is what is your fifth unit. The last unit is simplest unit, that is thin and thick cylinders. It is thin. It is thin cylinders. You are writing the expression for the Hope stress. That is what is known as circumferential stress as well as longitudinal stress, and we will be calculating the strains in thin cylinders as well as spherical shells. And the other topic is thick cylinders. Thick cylinders. Thick cylinders means it is the wall thickness is more, and in which you are going to derive one very important equation. That equation is called Lami's equation, and using Lami's equation, you will be calculating the various stresses and including the radial stress also. Radial stress in thin cylinders are neglected because of the small wall thickness. Here you are going to calculate the circumferential, which is also known as Hope stress, longitudinal stress, as well as radial stress also. So that is what is thick cylinders, thin cylinders and thick cylinders. And one important equation is called Lami's equation. You are going to derive the Lami's equation, and using Lami's equation, you will be calculating the stresses in the material. So this is what exactly the overview of mechanics of solids subject. These are the various chapter titles and certain important contents of the units. Thank you.